This lecture video is about solving exponential and logarithmic equations. And we've done this before. Now we're just going to lump in some natural logs in there and some common logs as well. And so the method that we're going to use is a little bit different this time also. When we solved exponential functions before, or exponential equations, we had made sure that we wrote both sides so that the bases were the same. So we wrote them so that we had some number b raised to the x is equal to some number b raised to the y. And then you could set the exponents equal to each other because the bases were the same. In the problems that we're going to do today, we will not be able to write them so that they have the same base, and so we'll have to look at another method for solving these. And there's a logarithmic property of equality. It's very similar to this exponential property here. If you're taking the log base b of something and it's equal to the log base b, so notice these logs have the same base, then a has to be equal to c. So here we're going to solve some exponential equations, and again we can't write the same base this time. So our first example is 3 raised to the x equals 8, and we cannot write this so that we have a 3, you can't write 8 so that it's 3 to some power. You can't do that. So we need another way to solve this. And what we're going to do is we're going to take the log on both sides. It does not matter which log you use, it just has to be one of them found on your calculator. And so it can either be the natural log or it can be the common log. Again, it doesn't matter which one you use. I almost always will do the natural log when I'm doing this. So it would be the natural log of 3 raised to the x equals the natural log of 8. And then we had a property that said that you could pull the exponent out in front of the log. So the natural log of 3 raised to the x is the same as the x times the natural log of 3. So we get x times the natural log of 3 is equal to the natural log of 8. And we're wanting to solve this equation for x, so now I can divide by the natural log of 3, which is just some number. And so the exact solution is x is equal to the natural log of 8 divided by the natural log of 3. So just make sure that you write natural log of 8 and the natural log of 3. I would say the biggest mistake that I see people making is just writing one natural log, and so the natural log of 8 divided by the natural log of 3 is not the same as the natural log of 8/3. So these are not equivalent to each other. So be careful of that. Now we also want a 4 decimal place approximation, so we need to do this computation in your calculator. So the natural log of 8 divided by the natural log of 3. And you should get 1.892, and it was 7/8 in my calculator, so I'm going to round the 7 to an 8. And so you want both of those solutions. Okay, so this next example is very similar to that. So we have 5 raised to the 2x is equal to 6.3. Again, I'm going to take the natural log on both sides of this. So I get the natural log of 5 raised to the 2x equals the natural log of 6.3. Now we can pull this exponent out in front of the natural log. So we get 2x times the natural log of 5 equals the natural log of 6.3. And we need to solve this for the x, so you divide by everything but the x. So we're going to divide by 2 times the natural log of 5. And so that gives me x is equal to the natural log of 6.3 divided by 2 times the natural log of 5. So this is our exact solution, and I guess let's put an approximate symbol here because we've rounded. And so I want the natural log of 6.3 divided by, and just don't forget to put this in parentheses, so that's what you'll have to type after your division symbol in your calculator. And so divided by And in parentheses, we want 2 times the natural log of 5. And so here we get, and I'm going to write this down below here instead, 0.5717, but then there's a 9 after the 7, so you have to round it up to 8. And then this would be the exact solution. Okay, our next example, e raised to the 2x is equal to 10. So up until now, you could have used either the natural log or the common log. It doesn't matter which one you use. When you have e raised to a power, it is slightly less work if you use the natural log than it is if you use the common log. So if I take the natural log of both sides of this, I'd get the natural log of e raised to the 2x is equal to the natural log of 10. And the natural log of e raised to the 2x, remember, is just 2x, because this has a log base e, and so this base raised to the 2x will give you the thing you're taking the log of. So this is just 2x is equal to the natural log of 10, and then divide by 2. And so the exact answer is the natural log of 10 divided by 2, and again, remember, you need to keep all of this. This is not the same as the natural log of 5. That would not be the same. And so then we want a 4 decimal approximation to this. So natural log of 10, and then divide that by 2, and you end up getting 1.15129. So I need to round the 2 up to a 3. And here's our exact solution. In this last example now, we have 10 raised to the x plus 8 equals 7. This time, because this number being raised to this power is a 10, I want to make sure I use the common log, log. For the same reason that we wanted to make sure we use the natural log with this one. So if you have e being raised to a power, you want to do the natural log on both sides. If you have 10 being raised to a power, you want to make sure you use log. If it's not an e or a 10, then it doesn't matter. And you will still come to the right answer if you do the common log here and the natural log here. It's just slightly more work. Okay, so we get log of 10 raised to the x plus 8 equals log of 7. And the log base 10 of 10 raised to the x plus 8 is just x plus 8. And this is equal to the log of 7. And then we need to subtract 8 from both sides. So we get x is equal to log of 7 minus 8. And remember, these are separate things. So you need to make sure that this is one thing and this is another thing. It's sort of like, you know, having the square root of 7 minus 8 or something like that. So this would be your exact solution. In fact, I don't really like to write a subtraction of something in the back. I would rather see negative 8 plus log of 7. Then it's a little bit more clear that this 8 is a separate thing. The 4 decimal place approximation of that, so calculate your log of 7 first. And then you want to subtract 8 from that. And we get negative 7.1549. And so I think that this second way of writing this is a little bit better and more clear than writing it in this way up here. In our next set of examples, we're going to solve the equations. This time they're log equations. Again, we want to give a 4 decimal place approximation and an exact solution. So in this one, we have log base 2 of x plus 2 equals 4. When you have a log equation, you want to rewrite it in exponential form. So this would be 2, remember logs are equal to the exponent, so it's going to be 2 this base raised to the 4th power equals x plus 2. Well, 2 to the 4th is 16, so we have 16 equals x plus 2, and then subtracting 2 gives us x. X is equal to 14. So there's only one answer we need to give for that one because our exact solution is just a number and it's not the log of something. Here we have log of 7 plus log of x equals 1. So you want one single log is equal to a number before you rewrite it, and addition becomes multiplication, so this will be log of 7x equals 1. This is a common log. It has a base 10, and so rewriting this in exponential form would be 10 to the first is equal to 7x. And last thing to do to solve for x is just divide by 7. And so we get x is equal to 10 over 7. And I guess if you're on my math lab, it will want a 4 decimal place approximation if it's asking for one. And so we need to compute that 10 divided by 7 on our calculators, and we get 1.4286. It was 85, but you need to round the 5 up because there was a 7 after it. In our next example here, we have log base 4 of 12 minus log base 4 of x is equal to 3. So subtraction becomes division. Remember, you want to have one single log before you rewrite it. And so this would become log base 4 of 12 divided by x. Rewriting this, so it's your base 4 raised to the third equals the thing you're taking the log of, 12 divided by x. And 4 to the third is 64. And then we need to multiply both sides by x. That gives us 64x equals 12. And then divide both sides by 64. And so x is equal to, let's see here, 64 divided by 4 is 16, so that would be 3/16. And again, if we want a 3 decimal place approximation for this, then that would be 0.1875. And that is actually not rounded, that's actually an exact decimal as well there. Okay, back up to example D. Natural log of 3 plus the natural log of x minus 1 is equal to 0. Again, we need a single log, so rewrite this. Addition becomes multiplication. So this is the natural log of 3 times x minus 1 is equal to 0. And then we're going to rewrite this. Natural log, the base of the natural log is e. So it's e to the 0 power is equal to, and is equal to 3 times the quantity x minus 1. And you could distribute that right away and write 3x minus 3 here if you wanted to. Anything to the 0 power is 1, so we have 1 equals 3x minus 3, because we have to distribute this 3. And solving for x, we want to add 3 to both sides. That will give us 3x equals 4, and then divide both sides by 3. And we get x is equal to 4/3, and 4 decimal place approximation of that would be 1.3333. Our next example here, log base 2 of x plus log base 2 of x plus 8 equals 4. So again, we want a single log over here on the left-hand side. Addition becomes multiplication. So we have log base 2 of x times x plus 8 equals 4. Rewriting this, we have 2 raised to the 4th is equal to x times x plus 8. So now we want to simplify this. 2 to the 4th is 16. And distributing this x gives us x squared plus x, 8x, sorry. And now we want to subtract 16 from both sides, giving us x squared plus 8x minus 16 equals 0. And so this is a quadratic, which means we need to try to either factor this or use the quadratic formula. And so can we factor negative 16 so that the sum of those two factors will give us a positive 8? And 4 and 4 might work, but because this is negative, one has to be positive, one has to be negative, so that wouldn't work. What are the factors of 16? 1 and 16, and 2 and 8, and 4 and 4. And none of those would give me some combination of 8. The 4s would, but we need the difference of the two to give us 8. So this one does not factor, which means we need to use the quadratic formula. And remember, that is negative b plus or minus the square root of b squared. I'm going to erase all these factors now. Minus 4ac all over 2a. So what we have here is negative b, so that's going to be negative 8 for this problem, plus or minus the square root of b squared, which is going to be 8 squared, minus 4 times a, and our a is 1, and then times c, which is negative 16. This is all divided by 2a, but our a is just 1, and so it's going to be divided by 2. So we have negative 8 plus or minus the square root of 64, and then we have negative 4 times 1 times negative 16, so that's plus another 64, and this is all being divided by 2. So we have negative 8 plus or minus the square root of 128 divided by 2, and the square root of 128 can be simplified. Negative 8 plus or minus 128 is 2 times 64, and the square root of 64 is 8. So it's negative 8 plus or minus 8 times the square root of 2. And this is all being divided by 2. And so if you want, then we need to factor out a 2 on the top. And so that would be negative 4 plus or minus 4 times the square root of 2 all over 2, and then these 2's cancel. Okay. And one thing that you have to remember is the domain of a log function. The domain of a log function is that you can't take the log of any negative numbers. So the negative 4 minus 4 times the square root of 2 is not a solution to this. So the only one of these that works is the negative 4 plus 4 times the square root of 2. And so if you do that on your calculators, the 4-decimal approximation of that then is 1.65, and it's 685, so that would round to 69. In our next one here, we have log base 3 of x plus 2 minus log base 3 of x equals 2. So first we need to rewrite this subtraction as division. So that would be log base 3 of x plus 2 divided by x, and it's equal to 2. Now we can rewrite it in exponential form. So it would be 3 squared, equals x plus 2 divided by x. Squaring the 3 gives us 9, so that's 9 over x plus 2 divided by x. And we want to get that x out of the denominator, so I am going to multiply both sides by x. That gives me 9x equals x plus 2. Gathering up the x's on the left, we would subtract x from both sides, and we get 8x equals 2, and then we divide by 8 on both sides. That gives me x is equal to 1/4, and that's 0.25. And that ends our lecture on solving exponential and log equations. Let me know if you have any questions.